Well, thank you very much. This is a topic that's very near and dear to my heart. So I'm the CISO of New Relic right now, so responsible for all aspects of all aspects of security. But I actually started out my career as a developer. If you want an idea of how long ago that was, I was actually doing IBM networking on HP 3000 mini computers. But after that, I moved various things, including doing things like developing CompuServe and AOL sites. But I ended up in application security at Intuit about 15, 16 years ago, and spent a long time sort of running that application security program. And during that time, I observed sort of an interesting shift where, when I started the company, it was mostly box software, maybe sort of the Web 1.0, and people were doing really long release cycles, and the security team was very siloed from the developers. And they could be siloed. It seemed to work for the most part because developers would have a 6-month release cycle, develop something, and then they could throw it over the wall. The security team could spend a month evaluating it. That all changed as we started to move more towards agile, DevOps, where we've got very short cycles, and we couldn't have a security team sort of spend that 1 month at the end. And so really, what we want to talk about today is how that's shifted, how security is moving more into the development world, or how it should be moving. And we've actually got a really interesting panel of people to help us talk about that. I'll start by introducing John Steven. He's currently the CTO of Cigital. It's an application security company. Also CTO at Codascope, a spinoff that helps actually, or that builds security tools. He's also co-editor of Building Security in the Department of IEEE Security and Privacy magazine, and then leader of the Northern Virginia OWASP group. Next to John, we have Guy Po. He is one of the founders of SNCC, which is a service focused on helping developers, once again, build secure open source code. Prior to founding SNCC, he was the CTO of Akamai, founder of Blaze.io as well. He's also written a couple of books on web performance, as well as an upcoming book, I believe, on open source security. Then finally, we have Omri Illouz. Sorry if I mispronounced your name there.
Got it right. Got it exactly right.
He's a CEO, co-founder of Perimeter X. It's a company that provides behavioral web-based web protection. Prior to that, he's worked at several companies, basically building and securing applications at scale. So with that, what I wanted to do is sort of give everybody about 5 minutes to sort of give, an opening statement, not statement, but basically sort of your thoughts, opening thoughts on this area, and then we'll get into questions. So, John, why don't you give it a start?
Oh, boy, first. So this, I guess, is to get the rant out of the way before the panel, right? So a few things I thought were important to take away from what I have to say, if nothing else. I've been doing application security for about 20 years now, and I've collected a lot of data over that time from a lot of different security assessment techniques, threat modeling, penetration testing, red teaming, code review. And you'd be surprised to find that the kind of testing tools that are out there today that you rely on find about 15 to 20% of the critical vulnerabilities that we end up reporting and fixing for people, 20%. If you were to run tools and their competitors, what you'd find is that each of them typically, the critical vulnerabilities that are reported are typically only found by one of the tools that you'd run. And what that means is that the information these tools provide is pretty sparse. We've found, and Microsoft has found over 8 or more years of analysis, that 50% of the things that we find that are really important enough to fix, critical stuff, critical vulnerabilities, are what we call architectural flaws. And architectural flaws are the kinds of things in design that you can't necessarily find with automated tools, or in fact, by definition, you can't find. Things like your business logic isn't authorized correctly, so you can ship before you've paid for something in the cart, things of that nature. And in fact, we find that if you're using things like the OWASP top 10 or the SANS top 25, that those aren't the top vulnerabilities. Those are the top vulnerabilities that security consulting firms or tool vendors know how to find. So they pimp those because they make themselves look good in bake-offs. What we find is things like authorization or misuse of encryption, or just not doing it right at all, are the kinds of flaws that are more common than those. So is all lost? Well, no, I don't think so. To turn the corner, just real quickly, think about how software has changed. We've gone from building code from scratch in C and assembly and C++. or God forbid, COBOL or Java, to really combining Legos, Minecraft style, of open source software principally, configuring that stuff correctly and being able to build vast systems as a result. And so think of your software like an iceberg and think of the risk of it as an iceberg. There's the stuff above the waterline that you've coded, that you know about. We need to make sure you do that stuff right. But let's go below the iceberg, right? And that's really where this panel, I think, lies. Make sure that you use the good security controls in the open source software that you have, because they're really getting good at building security controls in, actually. Make sure you use them for the right reason, right? Don't sign when you should encrypt or vice versa. Don't sign, then encrypt, encrypt, then sign. Make sure you avoid the bad stuff that's included in your open source software. And God forbid, make sure you're using the latest version and it's patched and configured correctly for security. Right? If we keep those 4 things in mind, we can attack that class of design flaws that I mentioned as 50% of the problem. Now, there's tools that can help with some of those 4 things, and unfortunately, we're going to have to think for the other aspects of it, using controls for the right reasons. So if I had 2 things for you to take home and nothing else, it would be think about the design and think about those 4 classes of problems as you engage open source, not just one of the pieces, what you're doing or whether or not it's up to date. That's all for me.
Great. Guy?
4 minutes.
Yeah, so I'm gonna, just to kick things off, I'm gonna contradict
Awesome.
John to do that. So I guess I'll follow suit on the 2 things, because I have 2 of those components that I talk about. One is definitely, everybody's aware of living in this world of change development, right? Development today looks nowhere near the way it was before. And one aspect of that is the fact that it's continuous. So development has become continuous while security has remained waterfall. So security operations, for the most part, still remain as gates, right? You stop here and I will audit. How you audit, tools, assessments, you can have multiple gates early on, later in the process. But in general, the process of security still remains as is audit, while development becomes continuous. So, having the security audits be separate from development was never a good idea, but it is increasingly becoming just entirely unfeasible. Continuous development has deployment, integration, whatever you want to call it, means that we as developers are very efficient, are much more productive at our work, right? We need to do less to produce more. But it also means that there's no opportunity for entities outside to scrutinize us. And to me, security, in that process, for us to be able to successfully continue using these continuous methodologies, continue using continuous, then we have to sort of embrace some of the security components in it, right? So there's you didn't lose a son, you earned a daughter, right? You lost the opportunity to do these gates, but you earned the opportunity to get all the goodness that we do around software testing and software assessment in the process of security. So you can introduce CI/CD tools that allow you to, or code assessment or code review or whatever step of that process that allows you to embed security steps that were previously not automated, were previously hard to assess, were previously reliant on a certain level of expertise. So it's not quite a contradiction to the fact that you have to sort of design and architect yourself, but I feel like one is the most immediate opportunity that stands before us is to turn this negative to a positive, right? When you talk about the DevOps transition and introduce these tests, security actions into the existing quality processes that we have throughout our development process. The other attribute that is a little bit more tactical, but I think important, is that as another aspect of change in the world of modern development is the use of open source. And I think when we talk about unpatched servers, we talk a lot about about servers, about these binaries, the fact that your OpenSSL is not of a certain version or that you have a very vulnerable image magic binary on your system. But increasingly, as we develop, our own software is made up primarily of open source packages, NPM packages, gem files, Maven packages. We just pull those in, and the vast majority of code that is running on our system is not ours. This code is mostly, the vast majority of people building it are benevolent, good-intentioned people but it is also entirely unscrutinized. Many of them are built with no security controls, with no understanding of security. Many have known vulnerabilities and known flaws in them. And there's an ownership problem. There's a problem there around who owns open source security. Is it that sort of, sole developer who on the evenings has built something awesome that you get to benefit and build businesses on, and you expect them to sort of drop everything when there's a vulnerability or to have the security expertise? Or is it you who consume these things as off-the-shelf software and don't understand this code and don't really deal with that? So I think it's a fundamental problem, but to me, kind of in this modern aspect, that's my sort of second takeaway, is we have to take ownership. As development right now, this has nowhere else to go. The only place that it can be resolved is this is a part of our code, and it needs to be fixed as part of our code. So again, this is sort of the other focus area that I have today, is about embracing that, and how can you kind of take some responsibility to these open source components and build the entire thing as something secure, not just the code that you yourself write.
Great, thanks guys. Great segue to what I want to talk about. I spent my entire career building products and securing them. So I sat at both sides of the fence. The first part of my career, I engineered products. I built web-scale products, ignoring every single security best practice out there, like I'm sure many of you do today. The second part of my career, I was the security guy. I was chasing the developers. I was putting application firewalls on every parameter, on every gateway, just to patch these vulnerabilities, to find the places where the developers left it open. But recently I started thinking, why are we still behaving like this? Why is there a huge discrepancy between the developers and security? Those of you who've been coding 10 years ago had the exact same problem with the operations people. It used to be ops versus engineering. Engineering builds, and then ops operate the products. They were always fighting between them. But in the last few years with the DevOps movements, it's not like that. When you build software, you have the operations in mind. You have access to the tools. You talk about performance, scalability, high availability. Security needs to go through the same change. When you build software, your code needs to have security in place. You don't need to think about building the code and then protecting the code. The security people shouldn't be trying to find a vulnerability, run pen testing, put AppSec in place for you. The interaction between the user and your code needs to be secure in nature. And what I've been trying to do in the last few years is helping developers get the tools, get the knowledge into building better software that doesn't need to be secured externally. Not to mention that today it's becoming really hard to secure applications externally. On the cloud, on serverless architecture, you can't put an application firewall anywhere. So if there's a new vulnerability, the only way to fix it is in the code, whether it's open source or whether it's in your own code. And I think this is, hopefully, in 10 years, people will be talking about DevOpsSec, and we'll find something else to fight about.
You're here.
Yeah. So interesting. So both Guy and Henri, you both mentioned sort of the developers have to, become more secure, know more about security and take responsibility. How are developers supposed to know what security is at all? I mean, even the original awareness. And Henri, why don't you start since you last?
Sure. Awareness is hard because most people don't even understand how the bad guys, how the attackers abuse their systems. One thing we've done internally, because I have engineers that come without security background sometimes, so we take them through security orientation, and we always start by showing them attacks. That's the coolest thing. When someone abuses your code, whether it's classic SQL injection or a very sophisticated privilege escalation, you see the aha moment where the developer says, I want to learn more about security now. So I think not separating the processes, not having a security process which gives you, the developers, 100 Jira items to fix, but bring them into the process, bring them into the day-to-day interaction with the security people is the right way to educate them and get them more engaged.
You want to add anything to that?
Yeah, I think, so I agree around visibility, right? Security is kind of one of these, invisible unless something bad happens. So like surfacing it up to the top, sort of showing them what an attack looks like. I would also say that security is an aspect of quality. So you learn from it just like you would from bugs. You need to experience them a little bit, but it's about finding them, having you face them and actually fix those issues, and then you learn from them, right? Over the years, you've encountered this bug before, you try to avoid it next time, you think about it after. I do find I kind of stumbled onto an example. So at SNCC, we look at vulnerable packages. And really, we don't help you secure your own code. We help you sort of identify those flaws and fix them. But only clued in after that those are actually really good examples of bugs. The real bugs, they happen in like popular packages like Mongoose and Request and Express. And they're not theoretical, they're real bugs. So actually, when you find one of those vulnerabilities, looking at the delta, looking at what was the problem that was caused and what was the fix, typically they would have some fix. So you look at what did that author do, actually serve as really good examples for real world vulnerabilities, which we oftentimes try to create demo applications, kind of create samples, and this is like real world examples of real vulnerabilities, not something that was concocted in the lab.
So John, sort of add on to that. So talking about open source and a lot of the problems, are in these, components we're taking. How do we even know if somebody's thinking about security when they develop this? I was talking to a guy this morning, actually, we had breakfast together, and talked about the fact that when I actually, I'm a security professional, if I'm doing something at work, I tell all the developers, you've got to make sure this stuff is secure. When I'm doing something for myself, I just go and grab the, package that works for what I need it to. And I don't look at the security. And how do we get people to sort of think about that?
And you should, I think, do that. There's a few things here, right? I mean, there is no software nutrition label, right? There's no thing that we can look at to see how much saturated fat there is, how many cross-site scripting vulnerabilities there are, whatever, right? Good news, there are tools emerging, right, that automate the ability for us to figure out if the thing is at the latest version, and again, if there are any outstanding vulnerabilities that need addressed. That's positive. Remember, that's the point of the problem that I described, that we need to figure out if it's made of good stuff. So we can run tools like SNCC, and we can decide, is the thing made of good stuff that we know of, right? I will say that most people, and you said this, most people haven't thought about security. I will say that there are some people, the guys at Helmet, the guys at Node, the guys at SpringSource, are reaching out to security guys and saying, we're sick of being the butt of vulnerabilities. Help us fix this proactively. Do they get the esoteric stuff right? No, they don't. What can you do about that? I don't know. But what you can work on is, are you using the stuff that they have done right? Right? Look at the packages and figure out where they're giving you security controls, where they maybe aren't turned on by default, but you can turn them on. This is very possible because they love to brag about them. Go to their pages. They talk about, how they had this very special design pattern they wove in their security controls with. Isn't it fancy? It's going to save you time. And there are packages that go along with what you use that you should explore. So with Node, there's Helmet. With Apache, there's Shiro. Right? With Spring, there's Spring Security. There's usually a security control set in these packages in addition to what they've advertised. And then the final thing is, you've got to make sure you're using it for the right reason and you're making sure you're doing it right. I would say that there's a real problem here. I completely agree with what you said. Study the attacks. We call that the NASCAR effect, right? Why do you watch NASCAR? For the crashes. Why do you learn about security? For the hacks. Here's the problem. Developers are the most optimistic human beings on planet Earth, right? Why do I know that? Well, because you get a problem like, can you build this site in 3 months? And you go, yes. And you have no idea what the requirements are, right? How many users there are going to be. So we found that though the NASCAR effect works in teaching security, developers are intrinsically bad at thinking negatively. Good news. Operations staff, QA, your customers, they're really good at thinking negatively, right? Because they've seen it break. They're just cynical, right? So by going down the cube farm and talking to those people about what they expect based on what you're going to include, based on what you're doing, you can cover that final base, and you can get some of that negative thinking inside your potentially overly optimistic head.
And just to follow up on that, use tooling. There's so many new tools that are helping you visualize security. Just like the first time a developer sees a flame chart of performance and says, wow, this is how long it takes to deserialize JSON, you need to do the same with security. The first time you look at how your users, you think they're your users, behave, you suddenly say, wait, so 50% of my users are not really users. They're not really behaving the way I expect them. Do I have anything in place to block them from doing anything from cross-site scripting, SQL injection, login brute force? And once you start visualizing it, once you start understanding that there is a problem always, not only in the corners, this is when you'll start, when you build the code, make sure it's secure from day one.
Yeah. I think those are good tips. Just to sort of add one thing that's more sort of future looking. I think these are the things you can do today, right? So to scrutinize those, I wrote a blog post about this on Rising Stack specifically to nodes, boiling down to some specifically all open free tools you can use to help this. But I think long term, it will be nice to sort of try to get the ecosystem to be a little bit more declarative. I've had a fair bit of chats with GitHub, and I think there's interest there in an attempt to be declarative about those security. It'll be a great place if when you create an open source component and you publish it on that GitHub repo, you'd be able to just declare which security actions you've done, just so that you would know, and that would create a certain social incentive to celebrate the fact that you've done it. Right now, if you've spent a week auditing your code or your open source component, you get no points for that. If you found a vulnerability, you fix that vulnerability, and that's it. So there's really no credit for you to be had, not in a cynical sense. It's just in that incentives spark behavior, sort of defined behavior.
That software label is coming, but it is certainly not coming next year.
No. So that's sort of a long-term thing, which is, so I think as an individual, you can, if you create an open source component, you can, although GitHub doesn't give you like specific scaffolding, you can still be declarative to say, hey, this underwent these security tests. It's going to be hard to consume that well when it's one-offs, but if there's enough of that momentum, again, there's this reciprocity between what the platforms gives you, what GitHub gives you, versus what you can do yourself. So I think there's interest there, and that might be a longer-term path.
But we need to make sure that this happens with the developers, by the developers. Because if this is going to be an afterthought, if the developer is going to commit something, and then the security guy is going to come in and add the labels, we had 1 hour of pen test on this. This is going to be the worst.
No.
Because suddenly that's only available for this commit.
No, absolutely. This has to be, what I meant is not labels to say this is secure or not secure, but rather labels that say, hey, I have pen testing as a part of the CI of this thing, or I have spent time, or this uses crypto on all of its communications. Just sort of have security declarations about the package so that you can consume that and later on sort of filter by them or use them as barometers to say which packages are or are not suitable for your use.
Yeah.
So how much knowledge or how much of a security expert are we asking developers to be? I mean, should this be completely turnkey? I can just read the labels or whatever it is and rely on that? Or do I need to know something about the underlying security? And maybe another way to phrase that question is, am I working myself out of a job here? Right? Do we need a security team still?
Don't worry about it.
Yeah. Yeah, I think the reason I'm laughing is that we are asking the developers for a lot. And it's not going to happen overnight. To understand the levels and sophistication of attacks, you need to spend years. And this is outside of the skill set of most developers. I think going back to the tools, going back to the visualization of the attacks, and the secure frameworks. If we start with secure frameworks and just add secure codes, our lives are going to be so much better. So yeah, it's not going to be easy. I wish it was, hey, developers, think security tomorrow. No, there's a lot of education that needs to happen.
I think there's a gradation here. I think when you start talking about security, it's easy to dial the knob up to 11 and leave it there, right? But it's just like performance, it's an emergent property. Your best developers are the ones that know the performance implications of everything that they do and all their committers do, right? And the best developers will eventually be the ones that know the security implications. But JRandom developer or whomever doesn't need to know everything. They do need visibility. You keep saying visibility. I think visibility is key. Yep. Tools can provide better visibility, but think about the things that would put you out of business, right? If someone can ship a ton of TVs without paying for them, what are you doing against that? You maybe not be able to solve the most esoteric problem, but think about the big ticket items, and you're going to be doing worlds better than you're doing today.
Yeah. I think kind of along this line is, I think the ask for developers is to care more than to be the expert. So it's more about think about it and ask the questions. And then you'll figure out the answer, some through tools, some through getting the security team. But I think expecting developers to become security experts is, it's a full-time job for a reason. It's a job where there's a massive talent shortage for a reason, because it's not simple to just pick it up and go.
Good
But I think
news.
it's about caring.
It pays about 20-30% more.
Yeah.
And it's impossible to turn a security person into a developer.
Yeah.
But it is essential that a security person be code literate. Just throwing that out there.
Yeah.
Just out of interest, I'm interested in how many people here work for a company that has at least sort of one person full-time dedicated towards security. So probably about a quarter only. So what about those groups that don't have that security person? How did, we can make them aware, but how do they then get that expertise? If there's something that's troubling them, what do they do?
I think they go to the internet. So to an extent, a little bit tongue in cheek, but the reality is that I don't think lack of knowledge is the problem. Yes, there's always better resources, better sources of information. But I think if you have a question generally for these things that have been the same question that people have faced before, you can find answer. There's good education materials, I think from Digital and Codescope. There's OWASP has a whole wealth of information on their website that can educate you. One of the messier websites, but if you search for it, you can find a lot of gold in there. But I think fundamentally it's more about go search for it. If you have a question, sort of write it down. If you have a concern, write it down and get back to it. I think just like you would for any programming question, for any many different aspects about developing good software.
Anyone else with any thoughts on that?
No.
So we got him to be aware, to care. Now we're asking him to do something, and I've got my 2-week sprint. I got to get this thing out. Why am I going to spend my extra hours now actually running this tool, doing this research?
Oh, very, very simple. Because if not, then 3 hours into production or 48 hours into production, you're going to come back and you're going to have to fix a lot of things. And if it's not in production and you have a CISO that runs, dynamic and static testing, then it's going to fail QA, hopefully. But it's technical debt. Any minute you save by not thinking security and just rolling out to production means 10 minutes that you're going to fix down the road. Pure technical debt.
So is this, one of the things, challenges I've had for a while. So we used to talk, a long time ago, even when I was into it, about wanting developers to take responsibility for security. But always had a hard time sort of pinning down what did that look like, and more importantly, how do we measure it? I mean, one of the things we used to talk about a lot is your annual performance review should have something about, security. But no one ever told me or figured out what that would look like. How do we measure if we're doing a good job, if we're making progress here? John, you haven't answered one for a while?
I was just going to cough.
Oh, sorry. Sorry about that. Yeah, you can cough, and we can come back to you.
Well, I would be interested, first and foremost, if you know what open source you're running, because you're probably running between 10 and 100 times as much code as you've written in open source. So we call this knowing the pile, right? You're putting a pile in production. Know what's in the pile. If you know what's in the pile and you know what outstanding vulnerabilities exist on it, there's perhaps someone who can help you with that. That's a start. So we talk about coverage in testing. Let's cover what your visibility to your open source and your open source risk is. Then let's get above the waterline and let's look at your coverage. How much of your code base have you covered with some kind of security control? Like you've got a mitigating factor in front of it, you've got some process step that you've applied to it, or you've got some knowledge you've welded into it with a security champion or by some other means. That's a pretty weak answer to your question. But if you're an army of one or an army of none, I'd say just knowing what's going on and figuring out what your coverage is and it's going to be close to zero. Let's try to get it up above 50 and 80, and then we'll talk about more advanced things.
Unfortunately, for most people here in the world, it's going to be check what you have in production, because most chances are that you are getting abused in production, regardless of how many security people you have and how many hours of code review you've done. If you have something in production, go and check what people are doing with it. Go and, it's really easy today to open up Tor, go to the dark marketplaces and check if anyone is selling known vulnerabilities to your website. If anyone is selling user accounts, you need zero skill set and a free hour. Implement a tool that will tell you, hey, do you know this is happening on your website? I've said it a few times, but the first step is visibility, because once you have visibility, then you know what to fix. I don't have an answer how to do it before production. It's a problem, even for us, for anyone, I think. We still catch things most of the times just before they roll out to production when we do some of the later code reviews and penetration testing on our product.
I actually have 3 answers to give you because I've had these conversations very recently. 2 I'm stealing from others. So I'll start with the one that's mine, which is make it declarative. So add a question to your pull request templates. Just sort of make it one of those questions that you frequently ask. I love pull request templates. That's what we do, because just like you submit a code change, then one of the questions is what security considerations should be reviewed here. Just make it a part of your code review process. I think it's a great way to just elevate this to, it's not a measuring thing, but it's about elevating it to process. I think it does wonders. The second I'll steal from Kyle, who runs AppSec at Optimizely. And he was talking about more for the AppSec team, so maybe that's more advice to your team, Sean, which is to just sort of celebrate successes. So find those opportunities where somebody took initiative in the development team and did something well, and just like give him whatever, like a hat or some shirt, or put some pictures, say, developer of the month, security is developer of the month, and just celebrate those. And then the last one I'll steal from Netflix from a conversation with Adrian Crockford, who was their CTO. Who what they did is they have the conformity monkey. So every developer is in charge of like shipping their own component and their own like they're in charge of the microservice or the things that they deploy. And there is a monkey, one of their many monkeys, that goes around and just checks if it conforms to some things, and it would run some tests on it, or it would try to break it. And if there's a problem, you'd get a page. Even if it's 3 a.m., you're going to get a page, and you'll be woken up. And that's a really good way to both find those, but also educate you to not do that again if you're the one writing that code.
This might be a little bit off topic, but I'm just interested, one of the comments here made me think about sort of bug bounty programs and having, using those to help find your vulnerabilities for you, get other people to do your work. Anyone have thoughts about them?
Yeah, priceless. We do it all the time. We don't pay the big money like Google and Facebook do, but yeah, we'll pay a few $100s for a good vulnerability. It doesn't take a lot of your time. You need to have the program running on HackerOne or one of the other places. Don't be afraid. Yes, people are going to try and hack to get the bounty, but if you think people are not going to try and hack you to get the money another way, fraud or some different way to steal money from you, then you're wrong. Someone is going to try and hack you. It's going to be better if he comes to you to ask for the money than selling credit cards from your website.
I'd say I like the notion. I haven't seen a ton of experience with it. Google open source their capture the flag. So I think there's bug bounty. I like bug bounty as a general security poster when you talk about educating developers. I don't know that it's that valuable for you to have like a hackathon where all the developers try to hack the website as part of that, even if there's some reward, whether monetary or other, because the developers wouldn't necessarily be the best testers, the best testers. I do like Facebook open source their capture the flag platform, which they've used for education in universities and in various other places. I haven't seen, that's fairly recent. I haven't seen like very small organizations do it, but mid-sized companies do it as a day. As John pointed out, hacking is fun. That's the one, like you're doing risk reduction, it's all fear mongering and all that. The one kind of saving grace is that hacking is fun as an action, and it's very educational. So doing capture the flag as a company-wide event to educate the developers, I think is a good idea.
Yeah. So sort of getting back to those of us that have security teams, we're talking about pushing a lot of this to developers. What should the security teams be doing? What would they be focusing on in this world? And John, why don't I hand that to you?
That's interesting. So I run a security consulting firm that builds security capabilities inside companies. And then we spun off a product company. And I said, well, we should eat our own dog food. We should have a security group. And I was amazed to learn that I built a security group that didn't know how many products we had. So I thought we had 1 product and we had 5. And our developers were like, what the heck's wrong with you guys? So it's amazing how hard it is, to do right. One of the things that I've done is other than knowing the pile, knowing what you're running and knowing what's inside of that and what the quality of it is I've sort of disallowed my developers from trying to learn or think, and then my security guys, and I embed my security guys in with the developers. They have to code, they have to commit, and they have to get their pull requests accepted, otherwise tough. So making them responsible for actually delivering code, I think, is the number 2 thing in addition to knowing what your pile is. But the third thing is that I disallow them from going after everything all the time. And I focus on the one, like I said, the one or two things that would really kill us, right? If a customer can see another customer's data, or if we're building products that find vulnerabilities in people's software, we have to do production monitoring to make sure no one's using them for the wrong thing, right? And so I focused them on 3 or 4, really key items that I want to get right, because I know I can't boil the ocean, and I know that there's an ocean full of fish, that I need to boil. So I'm going to focus them in on little small things and get wins, and move from thing to thing knowing that I've competently done it. And by knowing what I'm running, by focusing them, and by making them responsible for actually delivering product, I think I'm forcing that sec DevOps thing, right, as opposed to just security and then the DevOps guys who try to avoid them.
Yeah. I think for me, the main purpose of a security team is education. You can't touch the code of every application in large organization. You can't enforce code reviews. You can educate. You can have weekly presentation, talk about the attacks, present the value of security. I know that this will only work in an ideal world because today the security teams still have to cover the patches and the holes of hundreds of people in the organization. But if we can give them some more time, I think all they need to do is educate.
So we run a study called the BSIM study, the Building Security and Maturity Model, where we've gone out to the Microsofts, Googles, and we've asked the Facebooks, and we've asked them, what do you do for security? And they told us. We just listened and wrote it all down. So one of the activities that mature organizations have is office hours. Yep. Now you said, well, go out and ask. Go ask the internet. If your organization has office hours, even if they're once every 2 weeks, and people know they can ask, and people know because of your NASCAR events that there's knowledge there, that goes a long way. And we've seen that as a tremendous home run for mature organizations, as simple as it sounds.
Can we ask a question? I mean, how many people here have seen a real hack on their application? I'm not talking about like a SQL injection, but a real hack. Wow, so few. That is sad. I promise you. I personally guarantee each and every one here, if you write code, it has been hacked in production. Wow, so only 3 raised their hand. That is scary.
I think on that notion, what I like along the same lines is a rotation. So this happened in the DevOps path, which is, you do a rotation, you let a developer carry a pager for a week, and sometimes that becomes the norm even. But even if you just rotate, you take an ops person and you have them do a sprint with the dev team. I think that type of iteration, like if you take a developer and you have them deal with a security incident, doesn't even matter if it's their code, it's on their application, it's in their system, seeing what's going on, just it's so eye-opening. You don't need to do many of those. If you do them even once per employee or maybe annually, it's not a huge effort. They don't need to be, the most important people kind of in the dev team that sprint or in the security team on that incident, but just the fact that that's their job for this time is very educational and also creates personal connections for people to later on be able to interact more easily.
If you can achieve a ratio of 1 to 100 with those office hours and with that kind of rotation, you're actually going to get leverage, we found, out of the study.
Listen, security is fun. I know we've made it, or the security professionals have made it hard and annoying and process-oriented that developers don't like to touch it, but it's fun. When you boil it down to a game, there's a smart kid on the other side trying to hack your site, and it's your job to make sure he can't. Once you look at it like that, it's fun. When he wins, you want to know how. Make sure to embed yourself in the security process. Look in production, understand the hacks. It's going to change the way you code. It's going to change the way you architect applications.
So, I totally agree with that statement. I've always thought, once you learn about security, it's a cool thing, right? How the people hack these things. So for people who do want to learn more, what are some good ways developers can sort of learn about security, practice this thing? Anyone?
You already mentioned OWASP. I mean, OWASP has great. It is a 1995 website. I mean, that's but
it wasn't very good in 1995.
No, it wasn't. But that's what you get out of volunteers. But they also have WebGoat and other exercises, so they have their own capture the flag events. They have conferences. The conferences are less expensive than others. There's usually local meetups, and you can usually find really interesting or at least well-connected people that can help you there. It's definitely a great resource, I would say.
Yeah, we haven't been doing a great job in the security ecosystem to bring in new people. So if you go to the big events, DEF CON, Black Hat, RSA, or even the hardcore ones in Europe, unless you have reputation and experience, you're not going to be welcomed like an equal part. And I think that's something we need to change as security professionals. If you can come into an event and learn, really spend 3 days and come out with meaningful insights for your code, that would be great. Today, I can't say wholeheartedly that I recommend people to go to DEF CON. You definitely feel an outsider, but that needs to change.
I think the meetups, I like the meetups if you're willing to like spend a bit more time on it and just sort of get engaged. I think going to 1 or 2 meetups is kind of hit and miss about how well you'd be educated. But if you want to develop this as a competency, that I do think they're a little bit more welcoming, although generally I agree with the sentiment about the security community. I like not a huge fan of WebGoat specifically, but I like the notion. But I like the notion of sample applications. There's a bunch of them. You know, with Node, we have one called Goof, which has an exploits folder, so you can find some of these vulnerabilities in there, and you can play around with them and run the exploits. And that's sort of educational. I think it depends. There's like a different answer to this, whether you want to just like generally understand security versus if you want to practically understand like an action in there. So you're building an authentication component and you want to understand how to secure it, or you're asking, you know, I'm adding HTTPS in here, what are the right cipher suites? So for those pointed questions, I still think the best thing is to just ask the internet, like Google it up, find the right example. For general education, it might be those. I personally really like the core, the original kind of hard books for security. I like Bruce Schnarr's Secrets and Lies. Just because they teach the philosophy of security more so, because the technology changes so fast that the internet would be more up to date than any book really that had enough time to capture notoriety. But the concept of how the breaker mind works and why do people do it and what are the fundamental reasons you make the mistakes versus make the correct decisions and how attackers think, those are really good. So I specifically would recommend Secrets and Lies from Bruce Schnarr. It would not let you know which library to use. It would only give you the sort of the concepts.
Yeah. By the way, one thing, I mean, it's going to be a little bit of a shameless plug, but we're all here as vendors, but we employ a very different way to sell to people like you. We don't come in like IBM with a product, buy it or not. We do what we call consultative selling, meaning first thing we do is educate you. Whether you buy from me or not, that's besides the point. My people are going to educate you, are going to show you what's going on. I think that's a great way to learn. When there's a potential to pay, people have patience, and I see how much we invest in educating, telling, showing our potential customers, and just use it. I mean, it might waste our time a little bit, but yeah, definitely use us.
Abuse your vendors, yeah.
Yeah, abuse your vendors.
Also, I was going to say that
mine is like open source and free, so not all of it, but so just go to snyk.io and check it out.
I was going to say, if you're interested, some of us run I don't know if you have one, but an Amazon wish list that we just keep around for that question. What books, and it's got the classics on it, right? And what you will find actually is that there are some older books on there because you do need to flex the muscles of what is security design and what is the philosophy.
Yeah.
So if you just shoot an email, I don't know if you have one, but I certainly
have an email list that we can circulate some of these links after to the group. Okay, that would be good.
So I do want to open up to questions in a minute, but I did want to come back to one thing you said a few minutes ago, John, which is something that I think about a lot, which is you mentioned you wanted your security people to basically commit code. And I've always sort of been torn on whether that's a good thing or not, because I always get concerned that if the security people do too much, developers will start thinking this is security's job. And so I'm interested in thoughts about that, any counterpoints to it?
I think you've heard a common theme. It's everybody's, it's like the husband and wife play, like, where's the kid? I thought you picked him up from soccer practice. I thought you did. Like it's so where does it fall, right? It's everybody's job. We need to deploy secure software if we're working together in a firm. And so if I'm the security guy and you're the developer, then I'm probably going to handle, wielding the crypto and building the crypto library for you. I'm not going to roll my own. I'm probably going to handle the password storage, and pass that to you under the framework. But on the other hand, I don't want some, Baroque, medieval castle or church. I want production code that accomplishes whatever it is that we as a company set out to do. As soon as possible, preferably. Thank you. So, to me, I'm not worried about it being a bunch of stuff that gets thrown over the wall eventually. From my perspective, let's get this done. There's certainly enough security tasks that the security guys or girls could be co-opted into productive development full time. Is that a crisis? No, because I think we talked earlier about not really appreciating in a continuous build environment, having to stop the developers while we pour through their code in printouts. So if instead we're proactively avoiding problems, to me that's a huge win. And it puts their skin in the game. I mean, watch, if you have a security person that you dislike the practicality of their advice, force them to submit pull requests and force them to sit in the developer code review and watch that practicality go up like a knob, right?
Yes. I'd like to sort of separate the two things. Like there's engaging developers, or there's the rotation aspect. In that one, you don't expect the security person to write security code. You expect them to just write code, like to ship something that doesn't have to do anything with development. It's more about like take a sprint to sort of walk in the developer's shoes and just sort of get a bit of a feel for that. It doesn't have to be security related at all. And then there's the ongoing engagement of the security team in areas that require more security expertise. And those, I think there's other ways than just writing code in there, because there might be a scale problem there as well. But you might have code review. The security person might be involved in the code review and just engage, bring them into the flow so that it's not some book that you review after. Just make them a part of that, maybe a pair programming component. I'm not sure. Like, it probably wouldn't be cost effective given the salaries and the talent shortage to really like have your security people do the same amount. They're just doing the code that is security related. I think that wouldn't scale.
We had them,
an amount of engagement in that process probably would.
Two things we had them tackle in my product company is the Ansible scripts, because the Ansible scripts showed them that, holy crap, there are hard-coded credentials in the Ansible scripts. What are we doing? But it also showed them what the software looked like in production, which none of the diagrams reflected. And so that was huge for them because they suddenly knew what we were running and how we were running it. The second thing we gave them, to your last point, is session management, which has nothing to do with security, but everything to do with security at the same time, right? And so that gave them a feel for a very software-centric thing and a very scaffolding-centric thing pretty quickly.
And I think they can build, by the way, like Ansible or and like Chef, Puppet, any sort of deployment components. Also, the development team might build, the DevOps team might build a pipeline, and that opens up an opportunity, kind of back to my first point in my sort of 5 minutes, an opportunity to introduce a security component in it. So they might be writing very specific security code that just ensures that new provision machines conform to a certain spec, or that a certain pen testing test runs as a part of the CI/CD process. And the CI/CD process is a dev process. It would run with every build, but it may be that the step in there that does security is an opportunity for security to engage in something that would have to still be sustainable. Like, it would have to be now fast enough for the builds to complete, and it would have to do all of that, but might still be within their ownership.
So I'd like to open up to questions. I do believe we have a couple microphones going around. If anyone has any questions they'd like to ask the panel.
If I think about this from a game theory perspective, this is almost completely a competition game, but there may be some sliver of coordination. So is there any effort to try to communicate or signal hackers, or is there even any perceived value in trying to do something like that?
So we do internally, and we'll expose it externally at some point, something we call the value of an account. We do a lot of studies, dark marketplaces, for different companies, the top 100 commerce sites on the internet. How much does it cost every month to buy an account? And you'd be amazed how different the price is. This is where I really relate to that game theory practice, because if the price of an account is $4.30, it means someone buying this account can do a lot more on your website. If the value of the account is 20 cents, it means they're doing relatively less. So this is one of the signals that we use internally to understand if there's value in what we do. If accounts are available readily and they're very cheap, it's probably not a big risk. That is the best signal we can use today.
I think it's important to understand that different websites are being attacked by different tools or entities. So for the long tail of the web, for the vast majority of the web, they don't have attackers that sort of sit there. Like, there's a talent shortage in the attacker space, just like there is in the, and like most people attacking are not that talented in that job, even if it's potentially even more lucrative. And most of the tools are being attacked using automated scripts. And to an extent, all you need to do is make it hard enough that they would go on to the next guy. Yep. And if you do that, to an extent, this is very competitive, but it is very hard to establish a benchmark. But if you talk about performance and how that drives the business correlation, and if your website is faster, then people would buy more for you, or if it's lower, they'd go to your competitor. To an extent, it's even more accurate. I think it's even more accurate in security, because these scripts would just attempt low-hanging fruit. And somewhere, depending on who you ask, but anywhere between 80% and 99% of the successful exploits in the wild are done using unpatched servers. And it's just because people were not attending to this hygiene. Maybe to sort of John's point, maybe it's just the things that we can measure, but it's definitely a large number. So that's an example of something that if you did that well, and again, for me, it's also with open source packages, but also just in the sense that, you used HTTPS, you did some of these core components. We're still so far behind that I think the good news is if you establish that baseline, you're actually in pretty good shape around not being that appealing to attackers, because they have such easy targets right next to you.
Yeah, it's worth follow-up. There's other statistics that both are true, but they provide competing views of the same elephant, right? 88% of the attacks are at the application level, handcrafted for the application. This client I had that came up with that stat, I was sitting in with their CIO, and they said, quote, actual quote, "Jesus Christ, if you can't get me a network map in a month, and my adversary can get it in 5 seconds, why don't I just pay them for it?" Right? And so it really depends. There's gradations of threat agent. There's gradations of asset value, right? 15-year-old metal-faced boy attacker running automation, organized crime nation state. The game theory changes in each of those boxes. It's interesting how much at the low end you can use silly things like deception to take the 15-year-old off the right path. On the other hand, someone who knows your network better than you do, there's a different kind of dance. What I would say is at the high end, it's worth a conversation afterwards. At the low end, there's probably not much worth you signaling, though in some sense, and we made this distinction somewhat, not a bug bounty program, but good hacker outreach, and even a T-shirt, which is a pretty small bounty, $25, can maybe provide the kind of signal you're describing.
What you don't want to do is like the hacker safe. There was an attempt to do like all sorts of logos, Oracle coming out with an unbreakable statement.
Oh no, don't do that.
There was a scan alert, which was a sort of PCI scanner earlier on that had a hacker safe logo. Those are like painting a target on your forehead. There's like, do not do that. That is not a good signal. Or it's a signal, it just, depending on what you're trying to achieve, I guess.
Yeah.
One back here and then another one. Sorry, what?
Maybe this question is a little bit more abstract, but I was wondering if any of you guys had an opinion on how far up you kind of see the burden of responsibility for security going in terms of where each player kind of falls along that product development process. So you kind of have, ops and back-end development, and then once you get into front-end development, you guys are talking about kind of knowing everything that's running. But if you're running like a Rails, or I'm sorry, if you're running like a React or an Ember application that has anywhere between 30 and 3,000 node modules, how exactly are you kind of prioritizing them to know? Because you can't know every single one. You can't audit every single one of those, given the size of like a team. So then even going further up there, does even visual design have a responsibility to security and I guess implementing UX patterns that try to get users to be better users and to protect themselves?
Yeah, I'll take this one. It's right up my space. So, first of all, if you consume a component, you're responsible for it. So you can talk about how feasible it is to you and whether your responsibility is in ensuring somebody else runs that test, and that might be there. But you're the one that picked the package, and it doesn't matter that in React you probably didn't pull in 2,000, but you might have pulled in 100 that in turn pulled in 2,000 total. In fact, that happens very often. But yeah, there's still your responsibility for pulling them in. I guess my statement is there is no other team that can keep up with you. Every one of these components that you've just added functionality and made you more productive, which makes you even harder to catch up to or to keep up with. So introducing some of those components, automation, I think this is very much an area where there are two solutions long-term. One is tools today in your CI/CD. Sneak is one of those, right? Exactly for that React example, you'll find the vulnerable packages. It's not all the risk that you carry from those components, but it's the most immediate one, and it's the easiest one for attackers to exploit. So that would find those vulnerabilities. You can fix them with our tools, and they'll go away. There are some dependency management tools out there that would give you maybe the more broader quality questions out there. So in Node, you might have BitHound, or you might have VersionEye that help you get a bit of a sense for that. And then, high level, over time, I expect we would have the second component, which is more of a sandboxing and monitoring component in production. It's not there. It's still a bit of a brave new world, as much as it feels like it's been here for a long time, and the security space is still catching up to it.
And I want to take the second part of your question. Yes, it goes as high as the user experience. One of the most sophisticated attacks we've seen was taking the user credentials from Facebook and Google and using that to log in to websites that allowed third-party login. Now, what can you do with that? There's no vulnerability. There's no hole on your website, but suddenly they had 10,000 fake users created on their website. So yes, it absolutely goes all the way to the user experience. You need to be responsible for every interaction with your website. It can be on the Linux server vulnerability. It can be in an open source vulnerability, or it can be in your own user experience and interaction with third parties that you use.
I would actually go one step further and say that I think behavioral access control and access control in general and the UX is probably the most powerful weapon we have in our design toolkit as security architects, right? The fact that Facebook and Amazon want to be the identity provider for the internet, and because of that, they engage the user and say, hey, did you just log in here? Does this look right to you? Right? We can do all the fancy monitoring on the rear end of production that we can imagine, but we can't solve the intent problem. But if we expose the intent problem to the user experience, we co-opt the user into their own security proposition and their own security posture, and we make them responsible and proactive as part of our security, controls, is what clamps.
And it's not buzzwords, by the way.
I mean,
we can show you that text, and we can show you how this
amazing.
happens and how you can block them in real life. This is a day-to-day operation for us.
I'm going to be the biggest, proponent as a security architect of this kind of approach that's out there. It's just so much easier than all of the magic you could pretend to invent on the rear end.
We so I actually gave a talk with a designer from the Chrome team about titled Security Ergonomics, which I can circulate around again in the email. We try to sort of boil down, and actually it was all about design and how can your user experience design help reduce it, and why do people make insecure decisions? And for us, it boiled down to different motivations. I mean, if you log onto Facebook, you want to see baby pictures, and that's just the way it is, and anything in your way is gonna fall by the wayside. The second is human limitations. I mean, yes, you might have that little indicator by that HTTPS mark, but you also have like this rich media content, and you're not really noticing that little yellow dot, or passwords and the like. And the third is just lack of expertise, right? You told somebody that a SHA-1 hash algorithm is used here and it's not secure. What is it that you expect them to do, right? So I think there's a lot of those components, and for each one of those, there is some guided. There's notions of opinionated design. Figure out what you think is more secure and guide the user to it versus just offering it to them. Talk about what's your continuum of forgiveness. Which areas do you want to fail safe versus fail secure. I mean, if you don't know if somebody broke the rules, do you let them in or do you not let them in? Where do you fall? So there's a bunch of these design principles, but I agree it makes has a lot of impact on the eventual security of your site.
I think we had one more question over here. Yeah.
I hate sitting down when asking a question, so I'm going to stand up. So I'm really glad you brought up the Facebook I'll just call it elephant in the room, because really I think a lot what we've been talking about so far is kind of dancing around the issue of social engineering. And the bottom line is whether you are a developer, a user, anybody, you're a person that is involved in this technological process. And what we can put any lock, we can put every key. If you leave the door open, it doesn't really make a difference. And I've come from a background of national security, and I'm kind of the person that kind of tries to exploit the weakest link in the room, or I was. I'm not that anymore. And it's very, very easy to do. And I think right now in a lot of technology companies, you have a lack of a culture of security. Both of my brothers are very high-level developers, and we always get in this argument about the appropriate level of paranoia. And I always come back with, it's not paranoia if you're right. And after I became a victim of the OPM hack, where everything and anything on my SF-86, if anybody knows what that is, was stolen by the Chinese government, it makes you feel pretty exploited. And I think when you have companies like New Relic that are sponsoring talks like this, I think this is the elephant in the room that really needs to be addressed, because everybody in here, whether you make the most secure code in the world and you audit it like crazy, if you're the one that gives away to the keys to the kingdom at the bar later on because you ran your mouth when you weren't supposed to, it doesn't really make any difference. So my question is, in all of your appropriate companies and the interactions you have with your customers and your fellow vendors, what are you doing within your companies to create this culture of appropriate paranoia?
Sure. So I'll twist it a little bit. I'll tell you what we do with our product. And I think this can help explain what we do inside the company. We try to look at the behavior of the user. Every user, not on the server side, on the client side, how do you interact with the application? Are there any indication of compromise, any indication of an anomaly? It's very nuanced and very hard, but you can usually tell if someone, like Guy just said, is using Facebook for its appropriate usage and then logging into your website, or is it now someone abusing Facebook to log into your website? I think for a human being, it's going to be very hard to understand the nuances, but with advancement in machine learning, you can start finding these little differences, these different anomalies that are there between a good human being and a bad human being, between a human and a bot, by the way, which is what we do most of the day. Is it even a human being? Because you'd be amazed how many times you think you have a user in front of you. It would be a normal user machine. It would be a normal browser. You'd see mouse movements. You'd see Facebook login. But there will be a bot or a malware driving the session. And that logging that you're seeing is actually someone creating a fake user from Google. And we call it behavioral fingerprinting. This is what we do internally. This is what we are selling. The only way to protect against social engineering and the most sophisticated attacks is to understand the behavior.
I guess, like for me, I think there's two things. One aspect is you just bring security to the forefront. So it's the security of your product. I think, by adding even the things we talked about, like pull request sort of questions about security, just raising the notion of security. And it's about how often do you have the conversation. So one aspect is just to talk about those. And it's about raising the profile. So nobody really knows what is the correct level of paranoia, but you can ensure it's just in the awareness. What you can rest assured is that if people don't understand that something would be a problem, there's no reason why they would do it. So you want to get them to the point that they even understand why is it a concern. The second thing we do that I think is more immediately practical is do what we can to secure our own dev environments, and I recommend this a lot, sort of secure yourself. There was an interesting example of this with the Xcode Ghost. Who has heard of Xcode Ghost? There's this, so this was like 6 months ago, something like that. There was a pirated version or some pirated version of Xcode, malware version, that some iOS developers used. And it wasn't actually harmful to them, but when they submitted an app to the App Store, it injected malware to the app and distributed that to all those users. And I think it was the first and maybe even only so far case of a real amount of malware in the iOS App Store. And what was interesting to me in that one is that the developers were a distribution vehicle. The attackers didn't care about the developers. They cared about the developers as a distribution vehicle for malware. And that, to me, is very much a lesson that I suspect happens more than we know, and that probably will happen. So in the world of NPM, you can publish without a password. So all you need to do is get into one developer's, well, frankly, this is true in Ruby Gems and in Maven, and so I shouldn't just kind of knock NPM. I just know this more. So all you need to do is get into one developer's machine who has the ability to publish a package to NPM, and they can publish something malicious that also is a worm, because they can add a hook in any one of these environments that would now run that on any other person that does it. There's the whole curl into sudo bash for you install. Like, just don't do that. It's not a good idea in any sense of the word. There's two-factor authentication on, like, put two-factor authentication on anything that matters. There's isolating environments. So I think the notion of securing your own environment, get your development team to just apply those things, force 2FA on everything, introduce another layer so you can't get from your machine directly to a sensitive server, but rather into paths. I think those are, it's again about one of those things where you're probably not being directly targeted. You're probably a part of some automation process. So if it's easy, if you make it hard enough, they'll move off to the next one.
Yeah. By the way, you mentioned iOS. We track hundreds of Chrome extensions that include malicious payload. People would actually, once they have 1 million installation on their Chrome extension, they want to monetize it a little bit, they'll go and sell to someone. They don't care what the payload is, but they'll let them inject JavaScript. An extension running JavaScript with full permission can do whatever they want. We're actually tracking hundreds, with many of them over 1 million installations. I had some installed, and you wouldn't believe what they do once they get control of your browser.
So that's a good story to, like, ensure that your developers know, and ensure that they either don't or at least scrutinize the
even on your website. On your website, make sure that the user right now, the interactions are not coming from an extension. But that's a topic for a different day.
So I would say, DevOps is about breaking down barriers, and continuous, deployment is about, again, breaking down barriers. But you can use those same techniques to introduce compartmentalization and the principle of least privilege, which when combined are two very powerful security capabilities. So one of the things we do that is not strictly social, but we try to wrap a lot of what we've just talked about here up into containerized deployment, into virtual environments, so that our developers' browsers, which they're doing God knows what with, are not strictly speaking the same environment that they're developing in and promoting from, right? So that's pleasant. We also do have certain things that are too privileged for them to be spread amongst a population, like keys, credentials, whatever, right? From a social perspective, I don't want them. I want them to be sharing code and contributing to open source. So I want social code, but I don't want keys and credentials to be in this. So we check that. Purely social. We run, even in our security consulting firm, we run phishing drills on our team. Our security consultants fail. The most senior of them are the most pissed when they fail and the most righteously indignant, but they still failed. That goes the whole way to the top. Someone asked a question about how far up do you go? We go up to the CEO, right? When our clients are intimately involved with us, we do them too, and we've phished the CEO of Fortune 50s, unfortunately, and then had to help them understand. But we want people to get into this habit of virtualization, compartmentalization, least privilege. We want them to be on edge, at least to some extent, with whom they're speaking. So we actually run brown bags and drills in addition to the exercises to help them understand, when they might be being worked, shoulder surfed, tailgated, phished, whatever. There's a lot. I don't know that there's a lot of publicly available stuff there. Unfortunately, if you go to DEF CON or Black Hat, you get just nothing but garbage, in my opinion, on those fronts. So we try to keep it very personal about what our people are working on, and try to keep it about protecting them. And we try to make it a value add to them, right? Like if I give someone a virtualized environment, then when they're traveling to do this meetup, they can go back to their bank account or their bill pay in a fresh browser that I've provided to them, and they don't have to worry about what they were doing an hour before. So it's not just about me, it's about them too, right? And by getting that comprehensive awareness at the social level, I don't have any measures as to whether or not I'm moving the needle, but at least I sleep better at night. I don't know if that's a good or bad answer.
By the way, one comment on events is O'Reilly is actually getting into the security space, and they're starting an O'Reilly security conference and books. There's one in New York, there's one in Amsterdam, probably going to permeate, which I think is very much a part of this sort of momentum. It's meant to be a defenders conference, first of all, as opposed to like the vast majority of conferences, which aren't attackers, they're a researcher or sort of a hackers. They're in theory a defender, but in fact it's all about like new hacks and new techniques.
We have high hopes for this event.
They're meant to be like very, very inclusive. So I'm involved there. I think Maria is as well. I don't know if you are, but I think it's a good one to maybe track and maybe attend.
So I'd like to ask each of you to give sort of one final thought and maybe a piece of actionable advice people can take away. I'll start with you, Henri.
Sure. Be afraid. No, seriously. Once you see what's out there, and I definitely relate to what you just said. Once you see what's out there, I promise you're going to look differently at your code. You're going to look differently at your application.
For me, I would say take responsibility, which maybe is a continuation of this or not, or care. I think, like, to me, the most actionable item, I'm a little biased here, is like, with, the amount of open source you consume and knowing if it's vulnerable components you're consuming in there is very easy. So if that's not your tool, sort of find the one security tool to add to your stack to just sort of make it better. But I think it starts from caring, from sort of accepting this as a responsibility that is a part of your job and not some secondary team.
Be afraid, take responsibility, and use what you're given. A lot of the open source packages out there have great security stuff in there. Don't roll your own. Use theirs, and it's already baked into the framework that you're using, so it's going to work better from a developer transparency and ease perspective. Also use what you're given, because there's a lot of open source security tools out there that make development faster. If you're not using them, you're, in my opinion, negligent, even if not legally. Use what you're given.
It's great advice, and I'd like to thank the panel very much. Very interesting, and thank all of you for attending as well. Thank you.
Thank you.